we're trying to finish the list data structure. We talked about the linked list and we talked about the array list. We compare them together, we implement them. We discussed about when we're going to use linked lists, when we're going to use array lists, what are the trade-offs, and all of those things. Today we're going to talk about the stack and queue data structure, which is basically, as you can see on the page, stack is also a specific type of list. So the only difference between a stack and other lists is that it has its own limitation. It has its own behavior. So usually we call this data structure a LIFO data structure, last in, first out data structure, and so it has to act like that. So when you're adding elements, it's basically, we call it the terminology of the stack as well. So we add element to the stack, we call it push. And when we remove elements from the stack, we call it pop. And so as you're adding element, you basically add everything on the top of your stack, and as you're removing element from the stack, you're removing them from the top of the stack. So here in the example, we're adding data 1, data 2, data 3 into this stack, and as you can see, stack was empty when we added data 1, so that's going to be on the top of our stack. And then we added data 2 is going to go on the top of data 1, and that's going to be on the top of our stack. And then data 3 is going to go on the top of the stack, on the top of the other element. So basically it's kind of like when you have a book, for example, then you're stacking books on the top of each other, right? So that's the same kind of concept. So when you're trying to reach them, the very first element is going to be the element that is on the top of the stack. So the implementation of the stack class in Java is going to, as you can see, add those methods in it. So empty, pick, pop. The pop method is, as I said, is going to help us to remove elements from the stack. So when we're trying to remove, we only can remove whatever we have on the top of the stack, and that's called pop. So you see the method pop doesn't even have any parameters, but method push do have a parameters because you're trying to push element into the stack. So when we call the pop method, whatever is in the top of the stack is going to be removed from the stack. So in the stack of data 1, 2, 3, when we call the pop, data 3 is going to be on the top of the stack, and the pop method is going to remove that. And then you call the pop again, you call the pop method again, the data 2 now is on the top of the stack, so data 2 will be removed. And then if you call that again, the pop method again, the data 1 is the only one in the stack, and that's on the top of the stack as well, so that's the one that's going to be removed. So another method that we have here is called peek method. So peek method is also, it's kind of similar to the remove or pop. So it's also basically pointing to the element that is on the top of our stack. But the main difference is that it's not going to remove it. It's just going to tell you what is the element on the top of the stack. All right. So those are some of the most important or basically the main important behaviors we expect from a data structure that we call it LIFO, or sometimes we call it FILO, right? First in, last out, or first or last in, first out. So data 1 was the very first element we added or we pushed into this stack. When we start removing the elements, data 1 was the last one. So basically when we add or push the element, the order was data 1, 2, 3, and then when we start popping them, the order was and data 3, 2, 1. So it's basically going to be exactly the opposite order. So the other methods that we can implement technically into the stack as well is going to be the search method. So we can search for a particular element in the stack, and also empty. So you can also notice the E symbol here, and that's for generic. We're definitely going to talk about generics. All of these list structures that we implement, linked lists, my linked list, my array list, and also here MyStack, we all compared all of them to generic types. The implementation in Java is going to use the vector data structure, which is kind of similar to the list, and it's going to, or array list, and it's going to use the vector to implement this stack. we're not following the Java library in this case, and what we're trying to understand ourselves how to implement our own data structure. So since so far we are already created my array list and my linked list, we're going to continue using those data structure, and this time we're trying to now create my stack. So that's what we're going to do together. We're going to create a class called MyStack, and we're trying to see if we need to use array list or my array list basically to implement a stack, or we need to use my linked list to implement our stack, and which one is better. We're actually going to do both, and just for do the comparison and see which one is going to be better. So we're going to switch now to our Eclipse. Oh, by the way, here we have some comparison here to compare all the methods that we already implemented in my array list and my linked list classes. So as you remember, my linked list class had add first and add last, because our linked list was singly linked list. So we had the pointer to the first, and we had the pointer or reference to the last, and then each of our nodes only point to the next. So it was easy for us to move forward into the linked list, but it was not easy for us to move backward into the linked list because we only have pointer to the next. So that's why adding first or adding last, or even removing first element in the linked list, in the singly linked list for us, was just order of 1, very fast, just copying the addresses. But then trying to remove the last element, we had to do a traversing all the way to find the n-1 element, so we can remove the element at position n when we have an element in the list. And so that technically takes us order of n. So that was not a very good performance. And also getting elements from the index, particular index in the linked list, it's not that simple, because you still have to traverse, and if it happened that index is really index n, or n-1, then you have to do order of n time traversing the linked list in order to get access to it. Also searching, either doesn't matter if it's array list or linked list, search is going to take us order of n. In the array list, on the other hand, add to the end of the list and removing from the end of the list, those two are going to take us order of 1, but adding to the beginning of the list, which is basically index 0, removing from index 0, as we explained, is going to be expensive, because now we have to shift all the elements to the left, or all the element to the right, in order to add or remove from index 0. And so getting element from any index, on the other hand, in array list is very fast, right? So we do order 1. We just go to that particular address and get the elements. It's going to be order of 1, because we already know they are going to be in the memory back to back. So if we're trying to implement our stack, we have the option to use it or implement it using array list, and we have the option to implement it using a linked list. Now here first I'm going to try to implement it using an array list. So imagine this is our array list. So this is kind of like a yellow line I have here, and I start adding or pushing elements into this array list, and I pushed A. So since we're going to use the beginning of our list, like basically at the beginning of our list is it's when the list is empty, so the beginning and end are similar, but basically we're adding element to the end of the list, and we're removing also the element from the end of the list as well. So since we're trying to so basically like a normal behavior, so we're trying to act like a stack, right? So whatever comes first has to be removed first. So as we're adding element into the list, so push A, when the list is empty, it's kind of like adding data to the position 0, right? So there's nothing in the list. And then the next push is going to be B. So B is going to be on the top of it. So it's going to go to index 1. And then C is going to go on top of that. So it's going to go to index C. So it's kind of like we're adding element into the end of the list, right? So calling it add last method. So push can be act like the add last method if we pick the add last method to implement our linked list, stack in using array list. And so the top of the stack is also kind of like as the size, right? The size variable. As you remember, the size variable in my array list is always telling me now what number of elements we have on the list. And if you want to add a new one, what is going to be index of it, right? So here are the same things happening when I want to add in, for example, element D or push D to the stack. I have to add it in the top of the stack. So the top of the stack in this case is going to be 3, and so size also going to be 3, right? So that means that size and the top is kind of like acting in a similar way. So if I want to find the a best method to implement the push and the pop to make our array list to act like in a stack or basically the LIFO data structure, then picking add list and for the push is going to be a very good option. Also, we can pick a remove last as a pop method because, again, the last element we added into this stack was C, and then when I'm trying to remove in the array, if I just call the remove last method or just simply remove method, it's going to technically remove C, which is a last element into this list. Or similar to the fact that we can say that whatever top is pointing to it, top -1 is pointing to it, right? So that means that is going to be removed. So remove last also can act as a pop. And so getting element from a particular index to tell us the pick is going to be basically getting element of index top -1. So our pick method can be implemented using the get element at particular index, and we know the index is always going to be size -1, or in this case we can also call the size top, so that's going to be the same thing. So as you can see, the complexity of push method and pop method, because we're using the add last to implement the push behavior and add and remove last to implement the pop behavior in the array list, though both are going to be order of 1, and so that means our stack is going to have very fast, and the complexity of it is going to be for pushing and for popping and even for picking, right? To pick the last element is going to be order of 1. We can implement the search, it doesn't matter, because in that case, search always has to go through all the element one by one, and in that case, it's always going to be order of n. So that is going to be the search method that we have. So push is order 1, pop is order 1, pick order 1, and search is going to be order of n. So but I have the choice to pick add first and remove first to implement that. So you can imagine if I do that, that means I always have to add things, consider the top of the stack as index 0, and then I have to keep adding things to the index 0 and removing them from index 0, which is both adding and removing, or basically both pushing and popping, is going to take me order of n, which is very, very expensive. So that's not a very good